Hey guys, let me fetch the cat. Nope, she went outside in the balcony. I'm sorry. You'll probably see her in a bit. Anyone around? Hello. Waiting for more people to show up. No? Nobody? Surprisingly nobody for this time of evening. Yes, I will. Wait for it. That's the whole point, but I have a story to tell first of all. Of course I'll tear it to pieces, and there's more to be torn to pieces around here. But story time first. By the way, did notifications go out? Because I'm not entirely sure I've seen anything yet. Right. So I think there's 5 people watching so far. So to all of you, hi. Everybody's still preparing popcorn. Well, I'm sorry. I'm of the better earlier than later persuasion, so. But nevertheless, welcome. Happy to have you. Hi. Oh. Hello. So I've already spoiled the first thing that we're gonna look at this evening. Hi, falling electrons. Did you turn the device on its side? That's why they fell out. No cats for the moment. I promise I'll change that. So, first of all, the story. If you remember last week, I had a little showcase of that chart recorder from the same company, from Bruel and Kjaer. So, turns out I met somebody when we had a calibration session at work. I met somebody from Trescal, Denmark. And he usually comes along for larger calibration jobs with the local teams to assist him because he's been a traveling sort of guy. His name is Sven. Mr. Sven, if you ever see this video, I said hello. We took I pestered him, like we chatted a lot and asked him questions. Turns out his main responsibility is the quantum Hall standard, which is really cool. And while he was an apprentice, he worked for Bruel and Kjaer. And in those times, when he was an apprentice, they were actually rolling the chart recorders out, so they were manufacturing them. And he told me that there's the linear motor that drives the needle back and forth was so complex and so hard to assemble that there was only one guy, the famous Greybeard, who was capable of assembling them with the requisite precision and repeatability. And yeah, so there was only one Greybeard in Bruel and Kjaer who assembled all of the chart recorders, and that he certainly worked on the one that I have. So that's really, really cool. And speaking of Bruel and Kjaer, I don't know if you know them that well, but Bruel and Kjaer were the best of the best in acoustics, and I think they still are in seismometry and stuff like that, in vibration measurements, and everything like that. And they've been around for a very, very long time, actually. And they're from Denmark, from Copenhagen. And they made beautiful instruments, always. Bruel and Kjaer are, it stands to show, it goes to show that these things are still alive, and this one took a plunge face first. The other one here has taken a plunge face first. I'll show it to you later. And apart from the needle, the meter on this one being dead and the other one being very dented and sort of broken, they still work after, decades. And let's talk about this one first. So let's split it in half, kind of like this. So this is a precision sound level meter, which is basically just a microphone, a very, very fancy microphone with a very fancy preamp and some attenuation and a couple of filtering stages and stuff like that, and a way to control the response. So basically the peak detector, basically how fast is the peak detector. And the thing was just supposed to measure sound pressures, but you could actually connect a lot of accessories to it. So in the manual you could connect it to accelerometers and all sorts of instruments. You could connect chart recorders to it as well. It has a output enable, an amplifier output on the front. It can be connected to this, which is an external filter. And yeah, it's just a very, very interesting device, and it's very, very nicely built. I'll take it apart just in just a second and show you what's inside. But as I said, let's separate it first in half. This was a standalone unit, this part here, and the bottom is an add-on. So it's just a filter, basically, in order to set basically the frequency around which you're trying to measure a specific, I don't know, noise or sound or whatever. And it's actually, this is a precision sound level meter because it was supposed to be very, very accurate. All right, so let me take the screws off. It actually works, so if I'm gonna try and power it up for you guys. You can see the indicator like. An old Hermley CNC center had a Bruel and Kjaer vibrometer on the spindle. It actually was the problem. What? The Bruel and Kjaer vibrometer was the problem? and reading the comments while I'm taking the screws out. So let's put this thing aside for a second and let's take a look at this because it's very interesting. I've never seen such a construction, and somebody has attacked this with the very misshapen screwdriver previously and has managed to dent and mangle the screws a bit. And if we take the cover off, we can see a range switch. Is it focused? Let me zoom in a bit. You can see a range switch with a lot of trimmers around it and some magnetic components. And I have no idea what these are. Now, my assumption is that there's more to find out underneath the knob. So let's try and take out the knob, if I could. I think I'm going to need the longer Allen key. Hopefully one of these will fit. Of course, it's not this one. Oh, by the way, if I sound a bit off, it's because I was very, very sick till a couple of days ago. I don't know what's going around, but apologies. It got me good this time. So I can't really tell how this thing is put together. Other than that, it's got to be underneath the knob here. Just give me 1 second. Let's try a different Allen wrench. Nope. Maybe it's a flathead. Nope. It's an Allen wrench, but an Allen key, Allen screw, but it's very, very weird and long. And I don't think I have anything to take it out with. Just a second. Oh yeah. Proxon to the rescue. Okay, so, and now, let me try and mangle this thing off of here. This is not going to work, is it? I should have come more prepared. Just a second. So that was completely unnecessary. Hi, mate. You've missed the boring bit. Nice synchronization there. So, wow, that's a lot of capacitors. Well, how else would you be supposed to make a filter? So resistors, trimmers on every stage, so the filter's frequency can be tuned individually, and then we have 1 microfarad capacitors and these very nice, I think these are polystyrene foil or something like that. Polypropylene, maybe not polypropylene, styrene, anything, something like that. And I think we should take a look at what these things are, because I'm not entirely sure. I've never seen anything like that. Probably some sort of magnetic component. And LCR filters maybe. And it's basically a bypass switch for the filter. That's all. How's everybody doing? So if you just joined at 7 sharp, like regular people, and not like myself, who started 15 minutes earlier, don't worry, you didn't lose much. You just would have lost the sight of me struggling with some nuts, screws, and you haven't missed the cats either. So the cats are still to make their contractually obliged appearance on the stream. This is spring loaded and I think it's gonna smack me in the face. Oh, no. So this is a transformer of some description. I'm gonna be a heathen. I'm gonna try and pry this off. Nope, it's not gonna get pried off. So these are some transformers, I think, because there's 3 wires coming out of them. Auto transformers, something like that. So a very complex, pretty high Q filter, I think. And that's what this thing is, basically. That's all. Okay, let me zoom out. Clear the deck a bit. And let's get into this bad boy. And focus. Focus. Okay, it focused. So what we have is a on-off switch with 2 ranges. It's actually response curves, ABC, linear, and an external filter, which is the unit you've just seen me take apart. The push-pull function is the power on and off, and we have a range scale here. And how it works is the value set here using the combination of these 2 knobs is the reference level, and you measure by reading the meter over or under the reference value. So for example, if the needle was here, it would, and the reference was 100, then we'd be at 106 decibels. Okay, let's take it apart. You can see it's very beefy and solid. This thing came with a strap and probably a very, let's just say, inexperienced user of the device let the strap slip off his or her their shoulder, and it took a nosedive straight on the meter movement here. And that was it for the Bruel and Kjaer 2203. Just the meter. The rest of the thing works, and I'll explain a bit later. So what we can see here... Oh, let me do this first, because this is fragile and I want to preserve it as much as I can. So you can see the beautiful microphone capsule. This is a condenser microphone, which means it's a wobbly diaphragm, basically. And so there's condenser and dynamic and electret. Electret has its own polarization built into the membrane. A condenser is basically a capacitor whose dielectric, that's a bit more complicated than that, but it's a wobbly diaphragm with a metallization, and depending on the pressure, basically of the air around it, you get the membrane to move in and out. And moving in and out, you can sense the change in capacitance, and by sensing the change in capacitance, you can basically measure the, you can get the sound out. Okay, and let's take this side out, and I already know how to do this because I've done it previously. And I think this one will work, or not. It's this one. So we have 2 screws underneath here, which I didn't tighten all the way because I'm not a heathen. But I will take this apart almost completely, and I don't think it will ever go back together. No, don't turn it on, take it apart. And the turn it on part, I wanted to turn it on to show you what it does, but it kind of would be a waste of time because it just flashes a red light in here to show that it's working, and yeah, it doesn't do much else because there's no meter on it. And the output of the preamp does respond very well according to, the whatever input signal is. So probably the microphone preamp, which is very finely made, and the microphone capsule itself are still working and fine. And that's pretty good because that capsule is very, very interesting. Oh, and the dynamic microphone is just a wobbly diaphragm in a magnetic field with a coil of wire wrapped around it. So that's the main difference between the different types of microphones. Right, okay, so let's take a closer look, and let me start by zooming in so we can see the business end. Is it bright enough? Can you see enough? Can you see well enough, guys? Because I think you should be able to, if my screen is doing it any justice. So what we have here is the microphone capsule with the connection to it, and then there's a resistor coming from the bias and a capacitor going through to the gate of a JFET. So this is the main preamp basically, and then we have some more components leading to the rest of the circuit, and I assume these are either the constant current source for the JFET or something like that. Anyway, not very important. We can extract the microphone and I'll show you the connection, and it looks something like this. Focus. Focus. That's a Teflon insulator in there, and it's spring loaded. Come on. Oh yeah, should be good now. And there's a very fine wire which is part of the spring that passes through the Teflon, and this is the ground basically. And how these microphones usually work is that you apply a very large bias voltage in order of a couple of 100 volts to the capsule, and you pick up the signal from the moving capacitor basically. Oh, look who's here. Wait a second. You need to show this. I need to show you this, guys. We have a cat. A very curious little cat. I'll make her some room to take a cat nap. Can you see her all right? Okay, so considering that Pesto's here and she's very cute, I'll leave the cat cam as last time so you can enjoy her while I talk nonsense around here. Okay, and we have the back of the meter, and I was thinking to myself, well, what a crazy meter, it needs 4 wires, what the hell is going on here? And no, I'm just stupid. There's 2 light bulbs in the meter case, in the meter housing, which light up so you can see the thing in darkness. And the funny thing is, it consumes quite a bit of current, so it runs off 4.5 volts, so 3 D cells. And it draws around 100 and something milliamps. But if you turn on the light, that nearly doubles. So yeah, not very power efficient. But hey, you have a high voltage bias in there. So, and if we look around, we'll see a very cute looking board with lots of old, I think these are old germanium transistors. Zener diodes, I think so. Trimmers, and on the other side it's basically the same thing. I think these are exactly the same circuit but with different response times, because there's a fast and a slow response reading setting, and this is the attenuator basically. And there's an interesting aspect I forgot to mention about these microphones. If we take a look on the meter head, the range head, sorry. So the maximum range that it could get was 130 decibels, plus whatever was written on the meter, so 140 decibels. 140 decibels is huge. It's an enormous amount of sound pressure. It's basically being next to a shotgun blast. So, but continuously. So imagine the resilience of the membrane of this microphone necessary to withstand such incredible pressures. So this is a very, very stiff membrane, actually. So a microphone is more sensitive the flimsier the membrane is. But this is a very, very stiff membrane, which means that it doesn't have a lot of gain. It's very stupid to put it this way, but you know what I mean. And you can see the metallization there. And if you look closely, I think you'll be able to see that there's a small transparent ring, which basically is the delineation between the capacitor plate and the mylar that is holding the capacitor plate and the outer electrode. So this is a very stiff microphone, which enables it to withstand very, very high sound pressure levels, but it doesn't have a lot of gain. So the preamp has to be exquisite. And I forgot to mention that on this preamp in particular, we're going to run into our old friend Teflon. So if I turn this thing around, you can see there's Teflon insulators, and the sensitive legs of the components, the most important components, are placed on Teflon stakes, so to minimize leakage. And another funny thing is, in these sorts of microphone preamplifiers, the bias resistor for the microphone is in the order of gigohms, because there's no current, basically. The only thing you're biasing is a capacitor, and the only thing that's being extracted is tiny amounts of charge which get moved between the plates, but they're always returned. So what you're trying to bias is just the leakage current of the capacitor that's making up the microphone. All right, so what do you want to take apart next, guys? Let's start with this side, I think. We'll let the side decide. I'm sorry, I love puns. Did I mention that I love puns? By the way, I just heard, I'm not going to tell you who told me, but I just heard the very, very fun expression, and it's very characteristic of Romanian society. One more red book is one fewer barbecues attended. So this is pretty much the reason why Romanian society is not doing very well at the moment. Oh, and there's another expression which I don't know, for my Romanian counterparts in the stream it might be very familiar, but for foreigners maybe not. So we have the baccalaureate exam here, and passing the baccalaureate exam basically means that you can go into attending a university, so it's very, very important, right? So, and there's a thing about Romanian people loving like pumpkin seeds and sunflower seeds, and eating sunflower seeds at football, like, you know, Balkan people do. And there's a very funny way that people mock the importance of the baccalaureate exam, and it goes something, and I'm rambling because I don't have anything better to tell you while I'm taking this apart. There's an expression that goes something like, either if you pass the baccalaureate exam or you don't, the sunflower seed tastes the same. So I don't know, that might not be very funny for you foreigners, but it's downright hilarious for us. And the way it's said in Romanian is in a very grammatically incorrect manner, so it, you know, amplifies the lack of importance people associate with the baccalaureate. Right, let me figure out. I'm going to need to desolder a lot of things. I apologize. So this thing is gonna go to hell and back. So that is so true. We have the same in Bulgaria. Of course you do. We're brothers, despite everybody saying that we're not. Bulgaria and Romania are very similar. What? Which one? The sunflower seed or the what do you call it? The barbecue. Okay. I'm making a nightmare out of this thing. I'm sorry, but you deserve to see what's inside. And we shall do the same thing with the other stuff that I have to show you today. And I think you're gonna like it, because there's a lot of cool stuff that I scored this week. Actually, not this week, it's from past week, etc., etc. I don't know if you can see what I'm doing, but whoops. Right, one side, and we can take a closer look. There's also the power supply part here, which is just basically, as I said, 4D cells, 3D cells. So I think there's not much on this board apart from, I don't know, maybe are our graduates counting to 12? Why? So yeah, I don't think there's much on here. Maybe a couple of transistor gain stages and stuff like that. Let's look at the next side, which is more or less identical, but it's got a... Yeah, it's a bit different. Anyway, and we have... You know what? I'm getting tired of this. So, call me a heathen all you want. I'm doing this to save you time. Oh, and I'm gonna reuse the switches, I hope. They're very, very nice. So, range switches. That's all. And I'm just thinking about stuff, right? So I think what we have on this board here, this one, that I'm trying to separate from the rest, is this should be the bias supply for the microphone capsule, because if we take a look, I think this is a transformer. And by the looks of it, there's a couple of primary windings and something like a Royer oscillator here, and a bridge rectifier, and a 63 volt capacitor. That's too small. I'm looking for high value capacitors for the bias of this thing. Might not run as high a bias as I said, but you can see these are probably the transistors that drive the primary of this transformer. It might be also responsible for generating a negative voltage rail for the analog circuitry, and these are rectifier diodes, probably germanium. By the looks of it, they look like point contact diodes, and they're arranged in the... Come on, focus. The camera is very moody today. It doesn't seem to focus on what I tell it to. So they seem to be arranged in a bridge rectifier configuration. And that's the attenuator. And as all good attenuators, yeah, it's just a massive amount of resistors and capacitors, and that's about it. Whoops. And this is the front end. That's all. So this should be easy enough to. So this was the bias line. I'm pretty sure now that this was the high voltage bias. So if we chase that back, we might be able to find where it came from. So it came from this point here, which here, sorry, and it's coming from over yonder. It's very interesting. From around this side, I think. I don't know. I might be wrong about the bias voltage. It might not be as high bias as I said it might be. But anyway, probably this thing is serving multiple purposes. First of all, generating a negative voltage rail for the electronics, but I don't think it needs to, because it might be entirely AC coupled. So I don't think there's much reason for these things to be DC coupled. And having it AC coupled, you know, negates the need for a second voltage rail. And this doesn't look like the kind of circuitry that would have 500-600 volts on it. Let's look at some ratings. So 470 nanofarad, 250 volt capacitor. That's probably like 100 volts or something like that for the bias. Seems reasonable. Alright, so I've made a mess out of this one, but I'm not upset. It lived a long, fruitful life and was probably abused by Romanians, and I think it's glad to finally have been put out of its misery. By the way, soldering lead over cat. You can still see the cat. Okay, and now on to the next topic of the day, which is yet another Bruel and Kjaer. And it's also working, and I also don't care if I'm gonna destroy it or not, because I kind of have to start getting rid of some of my gear. I've actually started taking steps towards kicking my gear acquisition syndrome. So I've sold the nanovolt meter. I gotta ship it on Tuesday. And I'm not making any progress in that respect because I keep buying test gear. I can't lie to you guys. All right. So next topic is this. Well, let me put it this way so you can see what it is. So this is another Bruel and Kjaer. I actually have the grandfather of this one too, but it's far too big to even fit in the frame. So this is a tunable filter, and you can tune the filter like this. This had a giant dent in the front panel, and the needle couldn't move, and yeah, I straightened it out and it even works now. And there's a very fine detail here. There's a planetary reduction between the inner and outer ring here. So you can see that if I turn the outer wheel, which is the coarse adjustment, the fine adjustment moves a bit slower. And remember the chart recorder? Well, the chart recorder actually had a drive shaft output which could connect to this here. Let me show it to you. This is the drive shaft input. So this is a tunable filter, and you can have a microphone, preamp, or a direct input from something else, and an output which goes to, for example, the input of the chart recorder. And you can set a sweep from, I don't know, something to something. So for example, frequency range, if we set it here, it should be between 200 and 630 hertz. and it would start here and sweep and give you the absolute, depending on the meter function, RMS, impulse, hold, peak, minus peak, positive peak, negative peak, or max peak, either in log or linear response at this output. And this output basically drives the motion of the chart recorder. So that's how you would do frequency response analysis back in the day, before dynamic signal analyzers. Most of Europe, 10 primary school grades. Maybe. Romania has 8 primary school grades, then 4 high school, then 4 college, 2 masters, 1.5 masters, and 5 for PhD. So that's about it for engineering, at least. And look at this beauty. So I have no idea what most of this stuff is. I can tell you that this is a transformer, and there's a warning saying that all plug-in circuit board components to face front panel. So what it means is that, for example, if you have this plug-in board here, which is I think an amplifier. I have no idea. The component should face the front panel. So if I were to put it the other way around, stuff would be damaged. Interesting construction aspect. These are trim potentiometers, but they're not very easy to trim. So they're not like a multi-turn pot. So the way you're meant to adjust these is like this. You loosen the screw up and down wherever you need to set it, and then tighten it. And needless to say, that's not a very precise way of locking something. So let's take these boards out one by one and look at them, and brag about just how little electronics I know. I think this should be something. So there's a couple of diodes in here, a tantalum capacitor. No idea. Might be I have no idea what this thing is. Oh, it's a bridge rectifier of some description, because these are tied like bridge rectifiers. And it's doing something. I think it's the positive and negative peak detector or something like that. This has got a transformer or something on it. No idea. This has some weird transformers on it. Also no idea. This is basically a very nice gold-plated back. So this is a sliding contact. This is part of the attenuator section on the front. I'm just gonna yank these out and with little care. Components, basically. And what we have here is another section of the input attenuator with some trim caps and some resistors. And these are some very nice, I've seen these in Philips equipment previously. Bruel and Kjaer, not Philips of course, but I've seen this sort of connector, which has got to be a nightmare to assemble so that it works. But just look at how pretty these things are. See? It's mates very nicely. Maybe linear regulators. I don't know, Zener diode and resistor and transistors. Maybe a linear regulator. This is a potentiometer, and there's a few neon tubes in here, neon light bulbs. I'm pretty sure this is a higher voltage regulator power supply or something like that. Not entirely sure. This is a half populated board. Probably there were more options available. I don't know. This is probably an amplifier. a power amplifier. I don't know why you would need that, but there's a I don't think this one has it, so it might not be a power amplifier. It might just be another linear regulator. Yeah, they are beautiful, right? Beautifully made. The extraction system is very, very interesting as well. This is a couple of amplifying stages, I think, with filters. And this is very interesting here. Look at all of this. I think this is a due to where it is. I think this is something like filtering. Look at this. So I think these are Eero caps, and these are all JFETs transistors. For anybody playing at home, these are actually no, they're just BC107. Those are, I think, NPN transistors, and I have no idea what this component is. So it's just a shield, a thermal shield. So there's one easy way of finding out what it is, and that's snip. I daren't bother the cat to take this thing out. Oh, look. Oh. Thermally matched inputs. Wow. Let me zoom in for you guys. This is a treat especial. It reminds me of something. The nanovolt preamp input in my 181. Well, not anymore, mine. Same thermal paste coupling solution thingy, and I don't know what the component between them is. Let me wait a second. I need to brush my teeth. I'm just joking, of course. Oops. Oh, and it's not even touching it. It's probably one of those fire here with government cell broadcast, so need to watch later. Are you okay? I heard about the terrorist attack in Istanbul. Hopefully everybody's okay. Well, from you guys, and nothing bad has happened to any of you. Let's see what these things are. So, no, I can't do this to the poor thing. So, let's see. Maybe I can get in here. Maybe another. I think this might be whatever this is. I've never seen it before. I'm gonna get my fingers dirty to wipe this off. Can anybody tell what this is? A capacitor? Looks like a capacitor. No idea. And these are just some transistors. Let's do this and see what they are. There's not even any legible writing. LM709H for the big one. And the input ones S2N911. Oops. I'm gonna get demonetized. Yes, but I gave it away. I actually traded it for the tube tester. Wow, I've never seen. I think this is a matched JFET. I think this is a matched JFET because it's got far too many legs. I think this is another JFET current sink for the differential pair. It looks like a differential pair on the background, on the back side. And I think LM709H might be an operational amplifier. I'm not sure. Anybody know what a 709H is? And these might be just gain setting for that thing. So it might be a discrete JFET input operational amplifier thing with some gain setting for using these transistors in the feedback. I have no idea. Anyway, it's very, very interesting, and it's a beautifully designed board. This is done with quite an old op amp. Oh, thank you. So I was right, probably. Um, so probably, JFET input stage, current sync for them, same temperature in order to keep them tracking. Operational amplifier piggybacking off of the differential, output feedback going through these things, which are selectable. And they're selectable according to the configuration of the things that are here. There's nothing digital, so there's just output section attenuator knob here. And it kind of fits as well in the general place of the general location of the instrument. And next we have more beautiful, absolutely beautiful boards. Can you imagine how expensive this thing would have been? Hermetically sealed. So thank you, Jaromir, for the 709. Yeah, I was pretty sure it was an op amp. So LM301 again, op amp BC177. These are all very, very old components, but they're all in hermetically sealed packages. Just look at the quality on these things. It's just gorgeous. I actually feel kind of bad I'm destroying it like the way I am. But beautiful relay. A TI part, a BF178 transistor. Look at this. Pretty sure I've never seen as many hermetically sealed and dual matched BJTs. MAT12 is a very famous-ish matched transistor, and I think the one in the 181 was it was made by National Semiconductor LM394, I think. Super matched transistors made for extremely close beta matching, so HFE matching. 301, yeah, loads of operational amplifiers in this thing. This is quite modern actually if you consider it. So I think there's no tubes in this device. This is part of the attenuator again, and 1.25K, half a watt, Fraco capacitors made in Germany. Jesus. This is the bee's knees right here. Oh, and funny thing, I know it was designed by Bob Widler. Poor Bob Widler. He was such an alcoholic. So one of the most brilliant silicon designers, but a complete wreckage of a man otherwise. So sad. He died very, very young, I think. 47 or something years old. Anyway, much too young. The meter in the front unplugs. But it's kind of hard to do. So let me try and get this out. I don't know if I'm gonna be able to. Yeah. Yeah, one side is unplugged. I'm sorry, I'm trying to unplug this thing. And was it tied in? Well, let's look at another angle for the moment. So, by the way, I forgot about this part here. Focus, please. Uh, converter driver transformer, 11 to 1 to 1. I'm not sure what this might be. This is the main transformer for the unit. Yeah, people, overworked people tend to not live very long, happy lives. Actually, I think since I have the boards on this thing, I'm just going to put them all back together as well as I can. And not destroy this completely. I might try and... I haven't done anything completely destructive to it, right? Apart from removing this little... Oh, the cap had polystyrene foam inside it, by the way. So this is the main power transformer. I think I've said this like 20 times. And this is a converter transformer. I am not entirely sure why it would need something like that. Maybe it has a switching power supply inside for some reason. I don't think so. But anyway, it might have a bias supply for like an external preamplifier for, I don't know, a microphone, electret microphone as well. So let me just, before I forget about these things, let me just... Mozart, yes, Mozart was an extreme workaholic, and that's what led to his demise. And, and preventable disease. I just wanted to show you one really interesting thing, though. Remember I told you about the filter that can be tuned externally? Look at this detail here. So the end stops are marked by these two switches contacting this thing here. And the tuning is done using this beautiful, I've never seen such a beautiful potentiometer. It's a spectral, made in Italy, Milan. Hopefully you can see that. Milano. SP Elettronica. And it's a multi-ganged potentiometer. Look at this. So, or all of these are 0.17% linearity plus my 0.5%, and these are all, I can't read it. I cannot read it. Okay, 9.2K. So these are all 9.2K ohm potentiometers, and the linearity spec is the most important. So 0.17% of linearity over the entire scale. So that's very, very good. Let's look at another couple of interesting details in here. So I hope you can see the chain drive. The chain, there's an actual metal chain that drives the meter, you know, the thing that moves on the screen. And on the back side, let's see if I can find anything else interesting. A very, very early adaptation of what will become flat flex cables. I can't even begin to reach and pull it out, but you can see that is a very, very thin, flexible ribbon of electronic traces, like PCB traces. My exposure has gone a bit insane. Okay, and yeah, that's about it for this thing. Let me have a sip of tea and let me think about what I'm gonna show you next. Spicy tea. What could I show you? I have even more Bruel and Kjaer. Sleepy cat. Sleepy cat decided she wants to leave. Or not. No, she's just making herself comfortable. Cat camera, cat cam. I have never heard of Gerald. Bruel and Kjaer Bonanza. So I have another bit of Bruel and Kjaer that might barely fit on the table. Um, or I have quite an interesting device as well that you might be interested in seeing. The Bruel and Kjaer is vacuum tubes. The other thing is transistors and more modern. How about we see both? Which one do you want to see first? Right. So ZG007. Second one from here. No, no way. Here. I'm waiting for suggestions. ZL0012. Maker of television distribution equipment. Oh, you know what yours truly did when I took this cap off? The wire was actually connecting two traces, and I can't be bothered to put the cap back on for now. But to remind myself that the traces had to be connected to one another, I'm just gonna solder them back together quickly and put it back. So this is ZL0013, and the other one ZL0027 underneath here. Whoops. And this one plugs into I hear ya, both was named. So which one would you rather see first? Do you want to take a break from Bruel and Kjaer and then go back to Bruel and Kjaer later? My other cat is having nightmares apparently, because she's mewing in her sleep. One of my other cats. Just give me a few minutes. I need to take a breathing break. My voice has still yet to have recovered completely after the whatever the hell cold I got. That was nasty. And I can still feel it in my throat. Take care of yourselves, guys. Let's continue with the B&K, perhaps. Okay, I'll continue with the B&K. I don't know. 11? Is it 11? Yes. This looks like it came from here. Is it G005? Just in case everybody's getting pissed off at me, ZH011, I apologize. I'm trying to put this back so I don't make a mess out of 008, ZG008. And I'm also kind of stalling a bit for time until my voice recovers a bit, because let me just put it this way. I didn't go partying and I didn't go shouting on her anything like that, but man, my throat was absolutely devastated after that cold. ZL002. here. And this one only fits in here. And I think this one was the only one that fit in here. And this one is a ZE. And so here. And this one should be the one in here. And I'm done. Time. Right, though, actually there's two more, which are these ones. And they're 005. Whoops. Why didn't you say that you can't see what I'm doing? I'm so sorry. Deepest apologies. Okay, let's continue with the B&K. Give me just a second, so I need to take this out of here. You see what you're making me do? This is giant. It's even bigger than the other one. Hopefully the camera won't come crashing down. Just a second. Let me make sure that doesn't happen. Right. This is about 20 kilos. It's big. It's a random noise generator. You can still see the cat. Kitty cat. She's so sleepy. And this thing is another part of the same line of equipment, and it was made for frequency response analysis. And the point of this thing was to how do you determine the behavior of a system that's kind of like a black box that you don't really know what's going on inside. So if you have a speaker that you want to characterize in frequency response, what you can do, one of the things that you can do, is feed it white noise and measure the frequency response. So you'd put this into the speaker under test, put the nice microphone, sorry about the state of my hands, put a nice microphone in front of the speaker, feed the white noise into that, and measure the output of the microphone and frequency graph that. So you'd get, basically, considering the microphone is linear and blah blah blah, you would get the frequency response of the speaker. You could also sweep the input and measure the output, but yeah, it's one way of doing it. And this thing basically has I think it's a transistor noise generator, and it's got linear or weighted noise, so pink and white noise, I think. Yeah, and this is the meter time constant, so it basically tells you just how quickly the meter responds to basically the output level. You have a load, which is connected through an impedance matching transformer, and then you can select the impedance from 6 ohms to 600 ohms, or in this position it goes through this attenuator and exits here. So you can feed it into something like an external amplifier or something like that. And you also have a button that didn't work, an external filter in and out, and a remote control. I don't know what the remote control does, but anyway, it's in a big wooden box. It's very heavy. I'm gonna try and remove it from its residence. Oh, Jesus. and I made a mess out of my mousepad. I swear to God, this is the last time I'm gonna use this mousepad. Next time, I hope I'll have a brand new mousepad, because the state of this thing is just shameful. I can't really show you the back taking it apart right now because it's far too... Actually, I could. Let's do it like this. But I'm gonna need a bigger screwdriver. Which one of you is it? Apologies for the horrible noises. And voila. Wait a second. I need to ban something. Okay. Apologies. I'm big enough to have, what do you call it? Spam things now. Which is wonderful. Okay, so this thing also works, which is fantastic. And this thing is a bit more dangerous than the other thing because you can see, I hope, there's a couple of big power transformers in the top here. 1, 2, 3. This is one of these is the output transformer. I think maybe the smallest one in here, but I'm not entirely sure. Maybe not. Maybe yes. Maybe this one. I didn't go through it that carefully. I did clean I did clean it enough to, like, this was caked in dust and it was a nightmare to clean. But I couldn't clean it any better than this. So what we have here inside is one power transformer, which I think is the main one because it's going through to the input plug. This is the microphone input, I think, or this one. I'm not entirely sure. I can't remember exactly. And no, this one's the attenuator output. I'm sorry. So microphone input on this side. It's hidden by the cat, but you're not losing anything. This is a selenium rectifier because diodes weren't a thing there, and they didn't want to put something like an easy 80 or 81 tube rectifier in there. OB2 and OA2. These are actually voltage stabilizer valves. So this was fancy enough this gear that it actually had stabilized B+ supplies. And that is fantastic. These actually glow pretty in the dark when they're operating. They glow purple, which I don't know what gases they might have in them to glow purple, but anyway, they glow purple. Actually, wait a second. Don't try this at home, kids, but you shall see, hopefully with the cat cam at the same time. Don't do what I'm about to do. I'm a highly trained idiot on a closed race course. Oh. Boop. Boop. And on. And you can see the glowy glowy. Can you? Let me get the cat cam. Yeah, you can see the glowy glowy. And there's even more glowy glowy underneath. I'm gonna put the cat cam back. And I'm gonna turn these on. Ominous hum, run. Yeah, check. Does blink and lighten, check. Glowing purple thing, check. Exactly. Yeah, this is brilliant actually. I love this thing very much. It's very, very pretty. And we can have a closer look at this thing because I actually know a thing or two about these things. So this part right here, which you're not supposed to touch, and I'm not touching but pointing at. I might be out of chopsticks. I'm out of chopsticks. I'm gonna use this. This is voltage selector. You can see there's a number of wires going back to the transformer to set the taps. Rectifier, selenium, filter capacitors, more transformers. I have no idea what these are for. That's a feed through if I've ever seen one, going through to the attenuator or something like that. I have no idea. And EL84, this should be basically the output tube for the load, so the higher power output. And in the bottom of the thing, let me unplug this thing before I kill myself or set something on fire. I did qualify the statement previously by saying I'm an idiot on a closed circuit, so don't do what I'm doing. No, I'm not gonna go full electro boom. I told you guys I don't like that guy that much. And everybody's gonna shout at me because everybody loves Mehdi and I don't really like him that much. And what we have here, I think there's only a couple of transistors in the entire thing, and one of them is there. I don't know if you can see it. No, I can't see it, and I can't hold it. Barely? There. I think that serves as the noise source, which is then amplified, filtered a bit, and then amplified some more, passed on to the top board, and then fed into the power amplifier here, section here. Output transformer to the terminals in the front called load. And they also go through the transformer here in order to satisfy the attenuator output. So I actually connected this thing up to a speaker, but I'm not going to do it because it's kind of loud and you're just going to hear some white noise. But this is, I mean, you have to agree, this is completely, totally, unequivocally gorgeous. And yeah, the fact that it still works after all these years, that's... I know, it doesn't hold up very well. It's like, stop, and it just keeps on going till they're not around anymore. Electrocution is one of the worst ways to go, I think. And it's so 6 ohms, 1.2 volts. You can tell that's not a lot of power. So if you do 1.44 over 6, it's like a lot under a watt. But a lot under a watt is more than enough to excite a speaker in order to characterize its frequency response analysis, at least for, you know, small signal-ish. I think it's enough to get the Thiel small parameters, but actually I think you might need to drive the membrane harder in order to get the Thiel small. Thiel small parameters are basically the equivalent circuit of speaker. So basically the inductance, the inertia and the resistance, mechanical resistance and stuff like that in the speaker are made analogous with electronic components, and that's how you get the Thiel small parameters. Okay, let me put this away somewhere. And let me show you the last item of the day. Oh, Jesus. Right, so this is the last item of the day, I promise. It's quite an interesting one, actually. You can see Pesto is actually dreaming. She's in Neverland right now. This is a... Let me plug it in and show you. It's a 3-phase power meter of some description. I'll show you the back in just a second. So let me point the camera away from Pesto for a second and point it at the screen. I hope you're going to be able to see it. So you can see there's no options on this thing at all. It's in measure mode. And basically it's got 3 voltmeters and 3 current meters. And what it can do is measure 3-phase power, and then where is it here? Print it out on a piece of paper. And not only that, but the higher end models can actually measure like distortion and all sorts of parameters of 3-phase power systems. It can actually do apparent, reactive, active power, stuff like that as well. And you can set what you want to print out of it. And it's pretty accurate, actually. I did test it with I tested it against my 87.5 with the outlet, and it was pretty darn close. Like, it's lower resolution, so it's only, I think, 3.5 digits. Yeah, 3.5 digits, but maybe 3 3/4 if we're pedantic. But it was good enough for AC power, and it does apparent, reactive, active, angles, phase shifts, harmonics. There's option slots for stuff that I don't have, and the printer is pretty cute as well. So the only interesting board in the entire thing, in my opinion, because I couldn't really take the rest of them out easily, because there's a microprocessor here and some analog to digital converters on this board, I think, and some RAM and stuff. The only interesting board, in my humble opinion, is this thing here, which let's take a look at. So it's just 6OP177, which it's early 90s, exactly, something like that, and it's French, so it's already surrendered. You know that joke? I don't really like it because the French are actually very heroic all the time. I don't know where the thing from French people always surrendering during war comes from, but it's very stupid. I'm sorry, I had a sip of tea. So what I think is going on here is that, and some of you guys might know better, is there's some voltage transformers on the other board. Let me show you right away. Just a second. I am unscrewing as fast as I can. The construction is very nice. It's typical of the early 90s, late 80s, early 90s something. I didn't look at the date codes on the components, but I think this one's from 95, so it might be about the same age as me. Let me take, there's one more screw to take out, and I'll be able to show you the, oh, tantalum capacitors everywhere, because of course, why not? Did I mention my profound hatred for tantalum capacitors? We have a love-hate relationship. So, we have some reed switches, and this thing has a few ranges. So I'm pretty sure that these terminals here connect straight to the terminals on the back marked U. So there's three voltage inputs here with a common, and these are current inputs with a common. I don't know why, but anyway. So you can measure inline power and voltage on three systems, three phases basically. And I think what these are for, I think these are just for ranging. I think there's a couple of voltage transformers which convert the high voltage into lower voltage. And I think these are just true RMS converters, maybe, or something like that. Or I don't think even RMS, may be averaging. And 2803 drives the reed relays on the bottom, and 74HC08, I don't know, something some logic stuff. Maybe what is the 74HC08? Shift register? Counter? Anyway, something like that. So capacitors, I don't know why there's two of them. I think there's just filter capacitors for each op amp, but that seems excessive, like having both an electrolytic and the tantalum next to each capacitor, each integrated circuit. I don't remember if the OP177 is a dual or a single op amp. By the pinout, it looks like it's a single op amp. And clearly, these are the inputs. There's one going here, here, and here, going through these, and I think they're going further on the other side into these things, and then going out here. So, no, they're not current transformers. I'm pretty sure they're not current transformers. The current transformers are here. I was withholding valuable information. Can you see them? Yeah. So these are voltage transformers, certainly. These are ranges because it has several ranges for switching. Like it has a 70 volt range, 200 something, and 500 volt range. So 1, 2, 3, maybe 4. 3 ranges for each. So yeah. So this is the voltage board, probably, certainly, and there's got to be some current. That's very interesting. Those look like diodes, and that looks like a capacitor. So maybe they're just rectifying the output from the 3 current transformers and doing some. Oh, I hope it's sine wave-ish enough to convert. I'm not sure. This thing didn't seem to be very, very high-end. But still, it's a surprisingly nice quality. This doesn't strike me as very efficient layout, so I don't know. I actually don't really understand what's going on this board. It might be... So if they're not considerate... Look at Pesto, she's dreaming. She's so relaxed that she's actually fallen asleep, and now she's dreaming. And she was mustachioing. What other streams have you seen in your life with a cat cam? So real-time cat, always on camera, always having a cat. And without any animal abuse, because everybody who abuses animals should go straight into the boiler room of hell. Apologies if you're getting bored by me screwing things down again, but I don't know much about power analyzers because although I'm an electrical engineer, I have never worked in electrical engineering. I have only worked in electronics. So instead of working with thousands of amps or hundreds of amps or stuff like that, I've always dealt in the smaller quantities. Usually trying to make things consume less power because, efficiency. So you probably know a lot more about, whoops. And there's two latches in here, which are actually pretty nice. The blue things in here. These hold the board assembly in place. And in order to take out these boards here, I would actually have to take out the entire front of the instrument. And I have 5 more minutes. We can do that. I'm currently unscrewing the front. I don't think there's enough room for you to see that. Let me see. Whoops. I need a bigger desk. Has anybody got suggestions for big off-the-shelf desks? I have IKEA stuff, but they're not really robust enough. I'm considering having a custom-made desk at some point because I don't trust IKEA stuff that much. I'm not entirely sure of the quality. All right, so how are you gonna come out? Right. Oh, this is actually very nice. Just popped out. And display has 2 ribbon cables going to one board. And let me see if I can extract that board. Okay. So let's take a look at this. So we have some, I think there's our Toshibas. Yeah, Toshiba LCD drivers with a big 686, 80, 68, 68, 68, 68. Well, lucky you. I don't have enough place to carpenterize my benches. I have a design for a custom one because this is actually my bedroom. So in front of me over there's a window. There's my main screen around here. And behind me is the bed. And I'm thinking of making an L-shaped desk, but the problem is that I have a lot of pipes and air conditioning stuff running around and yeah. I don't know. Kitchen countertops don't strike me as rugged enough from what I've seen around here. I think I'm gonna go with a custom solution. Okay, and now we have a 68K Motorola. ROM, of course, I think that's a ROM. 68 to 30. I think this might be floating point math coprocessor or something like that, maybe. Yeah, even and odd RAM and ROM. I think these are RAM chips. Clock, glue logic, and two PALs. Wow. Programmable array logic. That's very interesting. And where did I take this out of? I think it was here. The intelligent solution would have been to not make them cross-pluggable. Jesus Christ, that's a very nice fitting connector in there. Ow. Ouch. Oh, and there's our ADC. Wow. Analog devices AD574. Jesus, that's a lot of processing power. And ADC32, Intel 4051. What is, I have no idea what these are. Conversion. This is a really nice looking ADC. It's one of those ceramic packages. It's gorgeous, right? I think this was actually worth the entire ordeal of taking it out. I'm just trying to figure it out. 74HC 373. I think there were shift registers. And this is a ROM. This is a ADC32. Is this? Can anybody tell me what these things are? So that's a Philips ADC32. I have no idea what that is. Intel 4051 556 8155, I think. Address latch for 8051 microprocessor. So, and the Mosel, what the hell is that thing? 6130L. Yeah, that's a lot of, I think this is a 8574 AK. I think this is a pretty beefy ADC actually, even for the time. Not entirely sure what happened here with these extra long pins. Oh, bodge wires. Yay, we found them. And there is one more board in here. Whoops. And this thing is obviously French because the battery is labeled pile. Oh, look at me. I was putting it in the wrong way. And this is more analog circuitry. Wow, these are some fancy capacitors. 22 nanofarad, 160 volt, 1% capacitors. Wow, precision capacitors. Another half dozen OP177s. 2 missing footprints. And we have LF1320, 1, 2, 3, 4 of those. And another LF389. These are, I think, low input bias op amps. LM393, 393 comparator, maybe, and resistor networks. Wow, this is an actually very interesting device. I completely apologize to the designers of this device. It is actually extremely nice. And by the way, there's a battery backup battery. There's a battery inside here. It's a 6-volt lead acid. I need to change it because it's totally, completely, 100% dead. I would take out the thermal printer, but that I really don't have access to. I would need to come in from this side, and that's just too much. Now, the question is, do I remember which board this went into? Yeah, looks about right. Let's see if it still turns on after that. Yep, it didn't blow up. It still works. Yay, didn't brick it. Excellent. Look at the cat. Right, so I think the next stream will be about something more interesting. Maybe perhaps something with 8.5 digits. And maybe maybe we can do something. I said I was gonna try and do some more videos, but I don't have the time to edit anymore. Between the working on my masters and work and wanting to have some spare time, I actually didn't really get to practice my guitar anymore, which is kind of a major bummer. So yeah, I think that will be it for today. I want to get my master's thesis as done as possible, as quickly as possible. And after that, we can do a couple of videos, actual videos about that, because I hope it will be interesting. And that's about it. I'm pretty sure that I still have enough material for like 5 or 6 videos, 5 or 6 streams, which should be music to your guys' ears. If you want anything in particular discussed in more depth and detail, please let me know, because I try to be very accommodating. And yeah, stay away from bugs, because I don't know what bug got me, but it got me really good. And that's about it. Say goodbye to Pesto, who's still in dreamland, and she's going to stay like that for a while now because it's her bedtime. And thank you for watching, and I hope you enjoyed a look into some... Well, I didn't go into as much detail as I wanted to, but I still hope I showed you some very exciting and interesting and at least pretty stuff, because I don't know, I now have developed a thing for Bruel and Kjaer gear. Thank you for watching. Thank you for joining me, and I hope to see you soon as well. Have a great week. Stay out of trouble. Thank you for all the kind wishes, and I will ask you to not forget about Pesto and wish her a happy evening, good evening as well, because she certainly deserves it. And that will topic of my thesis, multi-slope analog to digital converter. Thanks for joining, guys. I'll be off, and have a great week, and be excellent to each other. Bye.